Hello. When Corey and I started New Dawn Horizon, we both actually independently had reached the exact same conclusion that the way everybody was writing WCS/WES software was incorrect. What everybody was doing was the fast and expedient and easy to do, tough to maintain approach. They sell a system, they write a system, they sell another system, they modify the first system because it looks kind of like the second system and do that one. And then on down the line, you get 6 or 7 systems down the line. And what you end up with is 7 totally different systems that are very, very difficult to maintain. If you can't find the programmer who did the original system, support becomes a nightmare. And we had reached a conclusion that the way to do this properly was to sit down and, based on our experience, develop a modular base package that before we even go to market. We were fortunate to find that Ray Kokoza was willing to fund this effort of Conveyor, and the net result was we spent better part of 21 man years of R&D development over 2 years productizing this product before we went to market. We had 3 basic pillars that were our goals for this design. We wanted to be hit the field ready to run. We wanted the software to be flexible and modular enough. One of the big things that we designed into New Dawn was an integrated emulator. This software emulator acts just like the PLCs, robotic controllers, host interface, any other external device. We talk to it in the exact same format. The software is no different. What this allows us to do is it allows us to do much more extensive testing of the WES before it gets to the field. We get to test the software at many, many times the rates required for the required production rates. And it helps us detect some long-term issues. Things like where the database is constantly growing, we call that database creep, to where it eventually chews up all the disk space and the system comes crashing down, or memory leaks. These are sort of things that don't occur on day one. They don't occur during the startup period. They occur 6, 9, 2 years later. But they're devastating when they occur, and we want to catch them beforehand. What we don't want with our systems is a rule that every Sunday you've got to reboot it. We just want it to run. The other big benefit of it is, since we've tested it all before we hit the field, we can hit the field ready to run. We don't have a conference room full of, we don't fill your conference room with programmers making changes in the field. We don't want to make changes in the field. Nope, that's bad for everybody. The faster a system starts up, the more confidence the operational team has in the system, and that is everything. We want the operational system to believe, and if we want them to believe, we have to be ready, and our stuff has to run. Next. Wave or waveless. These are 2 basic concepts for how you build orders and how you pick. In a wave-based system, you're grabbing a group of logical group of orders. You pick them, ship them, then you run the next wave and do the same thing. Waveless, you start with a group of orders, and as orders get completed, you add new orders to it. What a wave-based system buys you is, it's always a balance between what's good for picking, what's good for shipping. The larger the wave, the more efficient picking becomes, because they have a bigger pool of orders to pick from. As they're making a pass through the pick module, they can grab more product per step taken. The smaller the wave, the easier it is for shipping, because they get all the product for their orders to the dock sooner, and it's much easier for them. So you need to balance the two. Wave-based productivity wave-based picking is very, very productive during the 90% of the process when you're picking hard. The downside is when you get to the reconciliation phase where you're trying to chase down the cats and dogs, production gets really, really poor. The goal in all wave-based systems is to make that reconciliation period as short as possible. Waveless eliminates that reconciliation period, but it does so at the price of offering a much smaller selection to the pickers at any given time, so their bang for the buck walking is not nearly as high, because as a new order gets added, the product for it could just easily be upstream of the picker. The slide next shows a graph of the various different concepts. The blue shows wave picking, and you got the period of high productivity, and then you got the valleys. The orange shows waveless, where your valleys are much, much smaller, but your overall productivity may not be as high. One of the things we frequently do is what we call wave overlap. Say the example, you have 30 lanes that you're routing to. We'll do the first wave for 15 lanes, and that wave gets about halfway through, we'll start kicking in the next wave of the next 15. That does cut down on the amount of orders the picker can pick to, but it's not really that significant. And what it does is when wave 1 is in its valley, wave 2 is in its peak. And the net result overall is a higher level of productivity. Now, all these various different concepts have their place, and you really need to research your particular needs to determine which one is best. Next.
And actually, Tim, I just wanted to highlight, in case it got lost, is that the Horizon software can do all three of these. So that's part of our due diligence process, is to determine waveless, or overlapping waves is best for your application.
Thank you. We are manufacturer agnostic. Our system will talk with all these various different material handling hardware. And the other thing that's very significant about us is our code is all Java based, which means it is also operating system and database agnostic. We prefer to run under Microsoft, but if you want to run a different operating system, QNX or a Unix-based operating system, run on that. If for some reason you want to run the Oracle database, we will run on that. It really, we drove very hard on the outset to not tie ourselves to any particular operating system. Next. This is a key to a lot of our modularity and ability to set things up. And we have a video that we'll jump to here in a second. But what we can do with a Java-based, a Visio-based tool, we can create your conveyor system. And we can do this in a very short period of time. And then using that screen you see in the lower left-hand corner there, we have a plethora of parameters we can adjust to configure your system. Let's go to the video.
To the videotape.
Okay, first off, we grab a sample recirculating sorter. And then we're going to go throw some diverts on it. Blow it up.
Not literally, I hope.
Put another divert on there. Then we get to where really the significant part of this is. These are all the control points. We add a scanner. We identify the scanner, and the system gives you defaults, which can be overridden, but 95% of the time are exactly what you want them to be. This is the first divert. Next divert, and you'll see that this one defaults to divert number 2. We put that in there. Now we grab one more divert for recirc, which is in fact in control standpoint, a divert because it's a destination like any other. We assign that to there. Now we go to save it to start to do parameters. But there's a lot of error checking in this tool. As you see, we go up there to save it. We're going to detect an error. We did not assign a PLC here. Our emulator is going to be, this thing sets up our emulator, and our emulator is going to act like a PLC. So now we've got a PLC in there. Now we go to start adjusting parameters. And first thing we're going to do is we're going to name this scan point whatever we want to name it. In this case, shipping sorter. And then you'll see here a whole slew of parameters. And by the way, these are just scan point parameters. You'll see, is there going to be a scale? And if so, how's it going to work? And we fought these battles so many times, we don't want to make these change orders. Excuse me. If you have a scale and you want to change the weight check mode, it's not a change order, it's just a change here. Here is, do we send a destination request before we assign it? Or do we already have that data downloaded? As you see, there's just a whole lot of these. And this is just on scan points. There's more on diverts, more on conditional directives, route directives, destinations, settings, etc. Here we're setting a number of consecutive recircs will allow a carton to do before we reject it. Here, this area here, we're setting up parameters for what the barcode would look like. Once again, if you change your barcode, we can adjust the parameters here, and it's not a change order, it's just an adjustment. Now we're going to go to diverts, and it's a whole nother group of parameters. And we can name each divert. And we're setting up who gets, what lane gets there in the case of a no read. What lane do we route to? What lane in the event of a no code? Now, frequently, all those go to the same lane. But if you run into a situation like a tilt tray, you may have one lane for product that you induct on a tilt tray that you don't need, another for no reads, another for multi-codes, whatever. In any case, all that flexibility is in there. If you use it, great. If you don't, that's great as well. Okay. One of the things that we do is we allow you to set up various different productivity modes for your system. In a period of low activity, you may not want to use all your lanes, but you want to, or what have you. You may want to change the way they're used. So you can create all these and save them and change them with a click of a mouse at any time you need to. All our parameters are real-time based. So if you change it, it changes immediately. You don't have to go back and reboot or anything like that. Next, please. Our system will work with any existing ERP or WMS system. Fundamentally, we learned a long time ago that you don't tell a WMS or an ERP how you're going to talk to them. They tell you how they're going to talk to you, and you say, yes, sir, and do it. So our host interface module takes whatever, we customize it to whatever way this WMS or ERP wants to talk. We then move that into our database in the format that we want it. And this allows us to work with any of these systems. We really don't care. And a lot of times, like with case with Manhattan, I've probably done 30, 35 Manhattan interfaces. Every one of them is different because from site to site, they're always different. A lot of times there's a gray area whether the WMS can do it or whether the WES can do it. Frequently, it's a lot more cost effective for those decisions to go to the WES because our labor rates are much, much more reasonable. Next. This is a huge thing for us. We want to hit the field ready to run. We don't want to be writing any code in the field. We want to get there. We've already tested it. We would invite the customer to our site to watch the system run, put their fingers on the keyboard before we get to the field. So when we get to the field, all we're doing is checking out to make sure that all the alarms that the PLC sends to us actually reflect the alarms they're supposed to reflect to. We're not changing the way we build ways. We're not changing the way lanes are handled. All that stuff was handled up front. This dramatically reduces the field time. And the problem with the WES part of the software is we are always on the end of the chain. The mechanical guys go install their stuff. They run a little bit long. The controls guys get in behind them. They run a little bit long. And the period of time WES had to check stuff out basically disappears because the customer needs that system running on a given date. So the better we can hit the field ready to run, the better we can meet that requirement. Next. Grow and change. Running a DC is all about changes. You get new SKUs, new customers, new requirements all the time. We designed into our configuration as many different changes as we've collectively done over my 35 years, Corey's 25 years of development of systems. We've encountered a bunch of these changes. If instead of making them change orders, we make them parameters so that we can adjust them. If you change scanners and the barcode format changes, it's not a big deal. If you were doing weight check and you want to change the way you do weight check, it's not a big deal. If you've got a different sort priority over time, you used to sort by store because you were shipping to stores, and now you're doing a lot more e-commerce and you're shipping by carriers. This is a non-issue. All these things we can accommodate with just parameters. Next, please. Power of choice. And this is a huge one because there's been a great deal of consolidation of WES providers in recent history where the major players, major manufacturers and integrators are buying the WES suppliers. And frequently what occurs at that point in time, if the customer, which had company X WES system, wants to do an addition to their DC, they then want to go to the company X to modify the WES software. And now they've been bought by some manufacturing integrator who then comes back and says, if we don't do the steel, we don't do the changes. New Dawn was started with a commitment from Ray Kokoza, the president of and owner of Conveyor, to never swing this stick. Conveyor's goal is to get repeat business based on the fact that they earned it. But if New Dawn software is at a customer site and the customer decides to buy their steel or whatever from somebody else, that is not going to impact. We are not going to say, oh, if you don't buy it here, we're not going to make the code changes. That is just not the philosophy of Conveyor or New Dawn. The other thing is we have an open API for all our UI, which means that if you want to develop your own screens, put your own logos on there, all that stuff, no problem. These are the base modules that make up the Horizon platform. Each of these stands alone. You can buy just container tracking, and you don't have to pick up all the rest of the stuff. Each of these, if they need a host interface, has a host interface module attached to it so that you can talk to the host, do conveyor tracking, and get your data back. And that's it. We can at a separate time, and unless I want to turn this webinar from a half-hour webinar into a 2-hour webinar, I can't go into the detail of all these various different modules, but we'd be happy to do that at a later time. But all these modules are ready to go as we speak. Next, please. Software support. We have 24/7 software support, but everybody has 24/7 software support. So there's really no big deal here, except for the fact there are a couple of significant differences. New Dawn is a software and controls house, but frequently we do just the software and somebody else does the controls. We make a pledge that we will never, on a support call, if somebody else is doing the controls, look at the problem, we get the call, look at the problem, say, oh, that's a controls problem, not our problem, goodbye. That's the last thing a customer wants to hear at 3 o'clock in the morning. We pledge to work with the controls house to resolve the problem until such time as either the problem's resolved or the controls house says, hey, this is clearly our issue. There's no reason for you to be there. If they do that, they have the right to call us back and say, hey, we looked at it further and we could use some help. We asked the controls house, and for the most part, on our customers, controls houses have agreed to reciprocate that, but that's one of the major differences in our philosophy. Because the customer never wants to hear, not my problem, I'm gone. The other big difference is, since we've modularized our software package, the database where the vast majority of support issues get resolved from one system to another looks very much the same. It's not totally unique. So the support engineers can get they're trained on the base modules. So the initial support engineers can solve the problems a lot more frequently. Another thing we do with all this plethora of parameters is when we get the system running and leave site, we save all those parameter settings. If we get a support call at 2 o'clock in the morning, one of the first things we do is compare, we have a tool to do this, compare your current parameter settings with our saved parameter settings when we left and everything was running good. If there's differences there, that gives a good target towards what changed, because support resolution is all about what changed. So it gives us a good target into what changed. Our logging, which I actually didn't even get a chance to get into, will record every time someone changes a parameter from one value to another value, timestamp it so you know what got changed, you know who was logged in when they make that change. This helps us, I mean, what software support is all about is solving the problem as quickly as possible. And the modularity and this data logging all facilitates us to a large degree. Next, please. Okay, this is just an example of a bunch of our screens. And this just gives you an idea of the user friendliness. You can see in the lower left there, we show pictures of the product. If you can give us the data, any screen where it applies, we're going to throw up a picture of your product to help the operations people determine what's correct. This is particularly good at QA, making sure the right stuff's in the right carton, but it applies in a lot of places, and it's just very, very useful. Once again, all our stuff's Java-based, so it's all web-based. It'll run on any device that runs Google Chrome. Thank you, and if you have any questions, we'd be happy to take them at this point.